All right, so your bell ringer, it's finished. So let's move on to our guided notes. Today, I can compare and contrast technologies that predict natural hazards. So basically, we're just taking what we learned on Thursday and Friday and adding on a little bit to it. So it's not going to be anything too crazy. Okay, so like this says, and hold on, let me make this bigger. There we go. Like this says, some natural hazards are predictable, meaning we can tell that they're going to happen ahead of time and prepare for them. So some natural hazards are going to be predictable. We can see them coming. We can get ready. Some of them not so much. Some of them they just kind of happen. And we kind of just have to brace ourselves, right? Now there are different pieces or types of technologies. We'll just say technology. There are different pieces of technology we can use to predict and study the impact. So there are some tools or technologies for each natural hazard that we use to either see them coming or to study how big of an effect they had after they became that natural disaster, after they did impact humans. So let's get more specific. Let's break it down. What am I talking about? So for each of these, you're going to see this is set up very similarly to Thursday's, how I'm going to go through each natural hazard, but this time instead of saying where they occur and their impact, which I'm still going to have up in this corner just as a reminder because I know it's a lot, we're going to talk about is this something we can predict and what is the piece of technology we use to study it. So first, right away, we have those earthquakes that happen at those plate boundaries or those fault lines. Are they predictable? Sadly, no. We can't really see an earthquake coming. They just kind of happen. The earth just kind of starts to move, kind of freaky. So the tool or technology that we use to study the effects of earthquakes is a seismograph. Seismograph. So whenever you see seismo, that means we're talking about earthquakes or we're studying vibrations in the earth. That's what seismo is for, vibrations in the earth. So what's going to happen is this tool right here is constantly moving even when there's not an earthquake. So there's this needle here and it puts scratches on this paper, and the bigger the scratch, the bigger the vibration in the earth at that location, okay? So if we've got just a little bit teeny tiny scratches, we've got a typical day, nothing happening, but once they are having some big scratches taking over, that means we're in the middle of an earthquake. The needle is moving because the earth is shaking. So it's measuring the tremors or seismic waves or the vibrations caused by the plates when they move. After an earthquake happens, we use this thing called a Richter scale. You may have heard about this before. We just assign a number to an earthquake based on how big the tremors are or the vibrations that were recorded by that seismograph. So if it's like a 2.5 on the Richter scale, that's a tiny, tiny earthquake. But if you've got an 8 on the Richter scale, that was a massive, major, major earthquake that's totally destroying things. So hopefully it's not too high of a number on the Richter scale. So yeah, earthquakes, not predictable, but we can measure them using a seismograph. Next, we have a volcanic eruption. So whenever a volcano erupts, I said they are kind of predictable. So what's going to happen is an volcano erupting, I almost said an earthquake. A volcano erupting is going to be caused again by tremors in the earth. So we're once again going to be using a seismograph. We're going to use a seismograph for a few things, so that makes things easier. So since the vibrations in the earth is what is going to eventually cause the volcano to fully erupt, again, we can study those vibrations using a seismograph. Now, we can somewhat predict a volcano erupting over an earthquake because volcanoes tend to follow a certain pattern, which I think I touched on Thursday. So volcanoes typically erupt within the same amount of time. So let's say an earthquake is due to erupt every 10 years. So if one erupted in 2000, around 2010, because that's 10 years later, it's probably going to erupt. Now they don't work specifically like exact timelines, but they kind of pick the same frame of time to erupt. But again, they're not 100% predictable. They just erupt when they erupt. And after they erupt, we use those seismographs to measure where or how big the tremors are or how big those seismic waves are. Other random things that you can use, you can also study gas emissions, which just means is there any gas leaving the volcano? So if you see a lot more gas or smoke leaving the volcano, we know, okay, an eruption might be happening soon. Or you can even just use a helicopter and fly over the volcano and look into it. And if you see things are changing, things are starting to bubble, it looks like it's about to erupt, then you can somewhat prepare. But again, when the actual eruption happens, it's not super predictable. It's kind of random. Okay, next we have flooding. Floods are predictable. So yes, we can see these coming usually because like I said, normally the flood happens after a large amount of rain or snow or hail or whatever. So we can see that coming, so we can predict, okay, there's a ton of water about to enter our river or lake or whatever, so we know a flood might be happening soon. Now, the technology we use, this isn't really technology to study the flood, this is more technology to prevent a flood from happening. So here we are going to use dams and levees. Dams and levees. So I know we've heard of dams before because you've got the Sardis Dam over at Sardis Lake. So dams are going to be those big, giant, they're pretty much like walls that block off large amounts of water. So if this lake were to fill up any higher, this dam stops it from overflowing onto dry land, right? Now, the Sardis Dam isn't that big, but the Hoover Dam is massive. There are some big, big dams around the world. Let me tell you, this is you might be able to tell looking at this picture, but this is a humongous dam. So hopefully that dam stays nice and strong. Usually with dams like this, you got to really inspect it. They make sure nothing's going to go wrong with it so it never breaks, because look at how much water that thing is holding back. Pretty serious stuff. A levee is very similar to a dam. Usually levees stretch out larger amounts of area. So a dam's usually going to be for like a river or a smaller lake, where a levee is like a lot of ground that it's covering. So the New Orleans levee, we talked about Hurricane Katrina a while back on Thursday. One reason why Hurricane Katrina was so brutal is because the levees in New Orleans actually broke. So they weren't even strong enough to hold back the hurricane. So when these levees broke, all kinds of extra flooding happened that shouldn't have happened. So there's a lot of talk about, are the levees now strong enough? Are we inspecting these levees enough as it is to make sure they're actually serving their purpose? So yeah, dams and levees. Next, we've got hurricanes. So are hurricanes predictable? Yes, they are. Thank goodness. We can usually see them coming a little bit ahead of time. Usually gives you a chance to plan or leave the area is usually what they want you to do for a hurricane. Just go up north toward drier land. So what we are going to use is, to actually see the hurricane coming, we'll use radars or satellites, and I'm going to touch on satellites more in the next slide, but a satellite is just that thing in the sky that you can take pictures of from super far away, so you can see things happening from a distance. So you can use this satellite to actually see a hurricane forming. Okay, now the technology we use, once we study how a hurricane has hit, we use what we call the Saffir-Simpson scale. So that is this scale right over here. So this is what we use to describe how extreme a hurricane is going to be. So you probably haven't heard it called this scale before, but if you ever listen to the news or the Weather Channel talking about hurricanes, they typically call it category 1, 2, 3, 4, and 5. And this is the scale they use. They use how fast that wind is moving. So if you know that you've got a category 5 hurricane coming your way, that is how fast the wind is blowing. So you You don't want to be there. You don't want to be around. You should probably evacuate. Next, we have tornadoes. And like I said, here we're going to talk about those satellites a little bit more. So are tornadoes predictable? This is another one that is kind of. So this actual storm itself, the buildup of the heavy rain and the winds, that we can predict. But where the actual tornado touches the ground, if that happens, you know how the wind circles and becomes this little cone-shaped spiral nightmare. Whether or not it touches the ground, that is totally random. We can't predict that. So when or where that happens, we don't really know. So the technology that we use to predict and study a tornado is going to be that weather radar and the satellite. And like I said, I'm going to touch on this a little bit more. So the radar, or you might hear it called the Doppler radar, this is what you see on the Weather Channel. I know we're a little young for the Weather Channel. We don't use it that much anymore, but I don't know, maybe your grandma or mom or somebody watches this. So this just shows how heavy of rain you're about to get in certain areas and the direction it's moving. So this radar shows, and it's based on color. Usually the darker the color, the more rain, the heavier it's going to be. So the radar shows how much and where it is moving. And again, the satellites, here's a picture of a satellite. This is just a big thing literally orbiting our Earth, and it takes pictures from the sky, and we can use that to collect the radar to know, okay, this is where the wind is moving, and this is how heavy the rain is going to be. And like I said, we use that for tornadoes, but we also use that to study these hurricanes. So satellites are pretty helpful. Okay, next we've got three more. Next we've got forest fires. Are these predictable again? Kind of. So again, these are often caused naturally just by heat. So that is super unpredictable. If you just have a tree randomly spark a flame, you can't really predict that, but you can predict where they're probably going to happen. Like we know, since California is super dry and receives little rain, you're more likely to get a forest fire out there. And down here over in like Sardis, you're probably not going to get a forest fire because it's not nearly as dry. We get some rain, it's colder. So that part of it is predictable. Also, if it's caused by humans, we can't really predict that. We can't predict if some crazy person's going to have a gender reveal party and just blow up something. So that can really cause a spark to cause a forest fire. So that part we can't totally predict as well. So the technology we use here, again, more satellite imaging, just to study how big the forest fire is from afar. And once you're up in the sky taking a look at the forest fire, you can kind of see where it's probably going to travel to next, just based on where the flames are facing and how the flames are moving. So again, you're going to use that satellite imaging to study those forest fires. Okay, this one is a little different, a little weird. So tsunamis, are they predictable? No, because remember, a tsunami is just an underwater earthquake, and earthquakes we cannot predict, right? So tsunamis we can't predict either, because it has to be that earthquake under the water that causes that massive wave to crash onto the land. Now, for tsunamis, the type of technology we're going to use is called, for short, DART. So DART is just short for Deep Ocean Assessment and Reporting of Tsunamis. Makes sense? So what DART is, and you really don't need to know the specifics of DART. Basically, you have something sitting in the ocean floor that is going to measure the vibrations of the ocean floor. And anytime there's a big vibration, it's going to tell this little floating device that's pictured right here. It's going to let this little floating device know. That's going to let a satellite know. And the satellite is going to tell a tsunami warning center. Like I said, complicated. There's like 1,000 steps. You don't need to know all that. Just know there's this nice, cute little floating thing in the ocean that's going to measure the vibrations of the ocean floor, and we call that DART. Okay. Last one. Super exciting. We've got those landslides. Now, are landslides predictable? No, because again, it's just the rocks randomly falling off of a mountain or a hillside, so we can't really predict when that's going to occur. Anytime we study the effects of a landslide, we once again, here it is, we'll use a seismograph because sometimes the earthquakes can cause landslides, so that's when we would use a seismograph. Or if there was a random landslide, we can refer back to the seismograph to see were there any big tremors or seismic waves that would have caused these rocks to fall. So one thing I want to touch on with the seismograph, because clearly it's very important, this is what they typically look like. You're definitely going to need this for tomorrow's exit ticket. Major hint. This is what the seismograph will typically look like. You again just have a pen and a weight, and it's just recording little scribbles because the weight is kind of free hanging, if that makes sense. So any vibration is going to cause it to shake. So it's just recording little scribbles, and whenever there's a tremor in the earth and the earth shakes, this thing's going to go a little crazy, making these scribbles super big. So again, seismographs typically look like this, but they can look like this as well. Anytime you have a needle making those little scribbles, that is your seismograph. Okay, that's every natural hazard tech. I know I went through it pretty quickly, but again, a lot of them use very similar technology, which kind of makes it easier on us, doesn't it? So if you have any questions, hit me up. I've got you, and I'll see you tomorrow.